All right, so two more to go. This is part two here of this lesson. I know this is really big lesson. We're putting a lot of stuff here put together. It's a lot to comprehend, so it'll be okay. We'll take this as we need to, at whatever speed, and we'll get there. So, starting here with the first derivative. Now, for this one and the second derivative are going to be pretty good. So we'd bring 4x to the third. Bringing the 3 down would make this minus 36x. Bringing the 2 down would make this plus 96x. That was 36x squared. Minus 64. Second derivative then would be 12x squared minus 3, or bringing the 2 down makes it 72x. That would just then become plus 96. So I can't write a 6 for some reason. And that's about as far as we got to go. That was pretty quick, pretty simple. So x-intercept now. So if we would do this by grouping, that wouldn't quite work out. But we have an x we could pull out. And so this would go to, we would have, let's see, x. So x to the third minus 12x squared plus 48x minus 64. Now, if we did, so if you think back to advanced math, we went through where we found, okay, factors of the front, factors of the back, and found out what was possible. Then we went through and found them. So if you do this, one of these is going to be x minus 4. And what would be left then would be, let's see here, we'd have x squared minus 8x plus 16. Yeah. Not bad for doing synthetic division in my head. So from there, this doesn't break down. Actually, it would. To x minus 4, x minus 4. So factors of 16, 4 and 4, if they're both negative, because this is a plus, we go negative in the middle. So they're all 4s from there. So your only x-intercepts are going to be 0 and 4. Y-intercept. Well, if I put 0 in, the only thing I'm going to get out is, well, 0, because this would go to 0, that would go to 0, that would go to 0, that would go to 0. As far as vertical asymptotes, well, we have no bottom, so there's none there. As far as horizontal asymptotes, again, we have no bottom, so there isn't one. Critical numbers, well, same thing here. If we set this equal to 0, we could pull a 4 out and have x to the third minus 36x squared plus 96. No, pull the 4 out. Hold on. So pulling the 4 out, this would be minus 9. 96 would be 24x minus 16. So same sort of a deal is I could pull an x minus 1, which would leave me with the same thing, actually. Believe it or not. So this will go to x minus 4, x minus 4. When you break that all down. So again, we would go through and go, okay, factors of 16 over factors of 1, and then you'd have to start testing them with synthetic division. I'm kind of giving you the shortcut because these videos are long enough already instead of going through all that. That would be something, again, talk to me in class about. When you come back, we'll get you caught up on there. So in that case, our critical numbers would be 1 and 4. As far as points of inflection, so on the second one here, that one's going to factor out. I'm kind of running out of room here, but we'd be able to pull a 12 out and have x squared minus 12 goes into 72 6 times, and 12 goes into 98 8 times, which would then factor out to be x minus 2, x minus 4. So our points of inflection are going to be 2 and 4. So our three that are different, no vertical asymptotes, these here are going to be 1, 2, and 4 that we're going to break this up by. Now as far as domain, well, domain's going to be all reals. So we're going to break it up by that. As far as symmetry goes, we have even, odd, so that's sum of both, so it's none. So, and then as far as end behavior goes, our leading coefficients to the fourth, so our end behavior are both going to be going up. Just keep in mind while we do this. So, negative infinity to 1, 1, 1 to 2, 2, 2 to 4, 4, and then 4 to infinity. So test value, I'm going to do 0, 1.5, 3, and 5. So f of x, f prime of x, and f double prime of x, and then my conclusions. All right, so again, I'm going to clear out my y equals. So my first one, were x raised to the fourth minus 12x raised to the third plus 48x squared minus 64x. So first derivative now, 4x to the third minus 36x squared plus 96x minus 64. Next one here we have 12x squared minus 72x plus 96. So, not graph. So as we look at these, I'm going to delete, going to delete these out, and we're going to have 0, 1, 1.5, 2, 3, 4, 5. So At 1, we're at a negative 27. At 2, we're at negative 16. And at 4, we're at 0. First derivative, we are negative 0, positive, 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 0, positive. Here we're going to be positive, 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 0, negative, 0, positive. So what does that tell us? Well, we're decreasing up. Because this is a 0, we're going to have a plus here, which means we are a min at 1 comma 20 negative 27, increasing and up. Now we're positive, but then we're a 0, so this is a point of inflection, because then we are increasing down. 0 means the test fails. And then we're increasing and up. So, and I'm gonna be honest. I'm gonna use the graphing calculator here to help me with this graph, which I'm gonna have to zoom. Okay, so this is what I thought. So we have our deal here. So we're decreasing, but we're curving up. So we're doing one of these until we hit our 1 negative 27, and then we're curving back up. And then it kind of starts to curve, but then we're back up. So we're concave up. We have our point of inflection, but then we're curving. So point of inflection here at 2, but then we're up. So the graph will look like that. All right, last one. So, working with trig functions here. So, as far as derivatives go, at least it's sine and cosine. So, derivative of the top, cosine would go to sine times the bottom of 1 plus sine. I'm going to leave the x's out for now, just simplify a little bit. Minus derivative of the bottom. Well, the 1 would go to 0. Sine would go to cosine times our cosine up top. All over 1 plus sine squared. Now, if we distribute this in, we're going to have sine plus sine squared minus cosine squared. All over 1 plus sine squared. Actually, if I didn't sub that in, the 1 plus sine squared and 1 plus sine squared would cancel, because then cosine, we would make this 1 minus sine squared. But it's negative, be a minus 1 plus sine squared. Hey, that's where I was going with this, actually. So let me rewrite this. Been a little while since I've done this, so be patient with me as we work through this. So if I have sine, I'll rewrite this as sine plus sine squared. Cosine, so we have our sine squared plus cosine squared equals 1, sort of a deal. So if to sub out cosine, I can have cosine squared would equal 1 minus sine squared. So this would be a minus 1 minus sine squared. So that would distribute. And so what we have here let me see, is that where I want to go with this? Must be. Okay. So not that I like to admit defeat, but it's been long enough. I'm rusty enough on this. What this goes to is a negative 1 over 1 plus sine of x. So somewhere I must have messed this up. So derivative of cosine would go to a negative sine. Ah, ha, ha, ha. There we go. It just hit me. There we go. So we would have actually negative sine minus sine squared minus cosine squared. So when we do this up here, we would get negative sine minus sine squared minus 1 plus sine squared. So that cancels. If we pull a negative out, we would have 1 plus sine over our bottom of 1 plus sine squared, which is why that cancels, and we're left with that. Okay. Sorry. Took me a moment. Eventually I got there. You guys are probably watching this going like, wait, if he can't figure this out, how does he expect us to figure it out? Number 1, never give up, never surrender. Number 2, that's why we're going to take our time and make sure we get this figured out and do this the right way when we're working on it. So even I sometimes struggle and I got to think a moment and then we get there. So just like that, never give up, always keep working. So second derivative of the top would be 0 times the bottom of 1 minus sine, 1 plus sine of x, which will all be gone, minus our top derivative of the bottom would be a cosine of x, all over our 1 plus sine squared, which that would cancel to be that, 1 times cosine, so we just get cosine of x over 1 plus sine of x squared. That was so much better. X intercepts. So here we're going to use the unit circle. Think about where is, because we want our top to be 0. So where is cosine 0 at? Well, cosine is 0 at pi over 2. Now with this, we're going to restrict our domain here a little bit. And maybe I should jump to that first. So domain is going to go from negative pi over 2 to 3 pi over 2, but not include those points. So those are the other, and I'm counting off here. So reason why is sine is going to be 0 at 0, pi, that sort of thing. But we're adding 1 to it, so we need to know where is sine going to be negative 1 at. Well, sine is negative 1 at 3 pi over 2. And every rotation around of that. So we're going to restrict it to this, so to one rotation from negative pi over 2 to 3 pi over 2, because that'll keep our bottom from being 0. Because sine is negative 1 at 3 pi over 2, so 1 plus negative 1 gives us our 0, so that's where that's coming from. And again, this is unit circle I'm talking about, so when we're straight down, our y is 1, sine is the y value. So that's why we're going to restrict it to there. So the only intercept we're going to have is here, because we're not going to have our bottom where it would also cross, where we'd also have an intercept. So that point won't exist. We'll cut it off. You notice how we have parentheses, not brackets. Those points are included. The y-intercept is going to be at 0 and at 1. So y-intercept, if we put 0 in for x, we would get 0 on top. I gotta think a moment. So, no, it's just gonna be 1, sorry. Because cosine of 0 is 1, sine of 0 is 0, but we have 1 plus 0, so 1 over 1, which is 1, which is why it's, yeah, sorry. Vertical asymptote. That's going to be at our negative pi over 2 and 3 pi over 2. Because again, that's what's going to make the bottom be 0, which is why we restricted our domain. So those are going to be vertical asymptotes. That's why we're going to go up to them and not past them. As far as horizontal asymptote, we're not going to have one here. And long story short, it's trig functions. So that's not going to end up happening. It's going to, and I can show you the graph. We'll get to the graph. You'll see why. Critical numbers is going to be none. Because on our first derivative, we had a negative 1 on top. No way to make that 0. Second one, for points of inflection, what makes cosine 0? Well, cosine is 0 at pi over 2. And then we're not going to be at either of the other ones, so that's as far as that one can go. Symmetry, there isn't going to be any. And again, that goes back to it being trig functions. They're bouncing back and forth. It's not going to be symmetric. So when I break this up, I'm going to break it up. So first I'm going to see, well, okay, so we have to include our vertical asymptotes. So negative 2, however, it's not part of our domain, so we're not going to have anything past that. From negative pi over 2, sorry, to pi over 2. At pi over 2, from pi over 2 to 3 pi over 2. 3 pi over 2 is going to be our last one here. So f of x, f prime of x, f double prime of x, and conclusion. All of a sudden I cannot write. So I'm going to use 0 here, and I'm going to use pi here. So putting this in our graphing calculator. and then we'll be done with this lesson. I promise there won't be stuff this crazy on the test. So my original here is I have cosine x divided by 1 plus sine x on the bottom. Negative 1 divided by 1 plus sine of x. Second derivative then, cosine x divided by, oh, need to close that, divided by 1 plus sine x squared. Oop. So, second table. Delete all these out. So, I'm going to put in negative pi divided by 2. 0. Second, pi divided by 2. Pi, and then 3 pi divided by 2. So, here we are undefined. At least we're supposed to be. And here we are undefined. Oh, mode. So, working with trig functions, make sure you're in radians. That'll make it a whole lot better. Now we get what we're supposed to. So we're undefined, undefined. And then at here, we're at 0. So first one, undefined. Then we're positive, we're 0, we're negative, and we're undefined. We're undefined, negative, 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 undefined. So what does that mean? Well, vertical asymptote, vertical asymptote. Here we are increasing down. 0, so it's a negative, so it's a max at pi over 2 comma 0. And then decreasing down. So, our graph. So at negative pi over 2 over here, we have a vertical asymptote. And at 3 pi over 2, we have a vertical asymptote. So our graph is going to do one of these. It's going to come down, flatten out, and then go. Interesting. I feel like this should have failed. Because but we're increasing and then we're decreasing. I feel like I did this wrong. I feel like this should be going like that. Double checking my graph. Ah, this is where I messed up. I got off. So we're negative, negative, negative. And then we're positive, 0, negative. So this isn't a max, the point of inflection. So I was right the first time. And our graph doing one of these. where it's coming down and then it switches and does like that. So there's another 30 minutes for 2 questions. That's it for this lesson and it for this chapter. We are going to be moving on from here to integrals. So no more derivatives. We're getting into the next part of math from here. So this will be it. It won't get any more complicated than this for right now. But please, if you're having questions, if you're not getting this, which for as bad as these last 2 videos went, I'm totally understandable if you're having some trouble with them. Please, we'll work through them in class. We'll take the time we need. We'll do whatever we need to do to get these straightened out. But please, let me know if you're having trouble. Pan me, email me, send me a message on Google Classroom. Remember, you can always pause it if you need time to write stuff down. You can also rewind it, watch something again if you needed to hear it again. That maybe it'll help make more sense. Otherwise, until next time, we'll talk to you later.